Hey guys, this is Mr. Guy. It is currently 10 o'clock at night, and I found out that my baby has an ear infection, so I will not be in tomorrow. However, you guys have a test coming up on Thursday, so I wanted to make sure that I didn't leave you guys hanging here. As many of you know, the goal for today was to go over the practice test. So you guys got this yesterday, you worked on it, and we're going to go over it today, and you're going to come in with your questions. Obviously, it's going to be a little hard since I am not there. So here's kind of the plan. I'm going to put up a video. It may take a couple videos. We'll see how long I have here. And kind of go over every single problem that's on your practice test. You do not need to watch every second of all these videos. In fact, many of you will only watch a little bit. Some of you will watch the whole thing. That's up to you. The goal is for you to figure out what are the things that you had questions about, what are the things that you're struggling on, and to double check those. If you want to kind of skim through and see and make sure you got the right answer on the things you think you did, then that's good. Otherwise, you can just jump to the things that you want to go over. So this is all about you guys and your test tomorrow. Make sure that you're good to go. And if you have any more questions for me beyond what's on this practice test, we'll try to get those answered tomorrow before I give you your test. Let's start in the very beginning here. We have to solve for x in each of these quadratic equations. They're all either already set to 0, or we're going to think about setting them to 0 to use our different methods that we have. There's kind of two different ways to go about this. You're going to need to, on the test tomorrow, solve quadratics in a multitude of ways. You have to be able to do at least one using completing the square. You'll have to do one with quadratic formula and one with factoring. So on these, I'm probably just going to do a quadratic formula for the ones that do not factor, because we have a quadratic formula or a completing the square one later on here. But just as a general reference, you should be able to do all three of those things. If we go ahead and take a look at number one's pretty easy. It is factorable. So we're going to go ahead and we're going to factor it. And we know that it's going to factor to x plus 3 times x plus 2. Please excuse my handwriting on this. I'm writing this with a mouse, so it's not going to be the most beautiful thing, but desperate times call for desperate measures here. Factoring this is going to then yield for me my two equations using the zero product property, that 0 equals x plus 3, and that 0 equals x plus 2. Please keep in mind that it is the zero product property. It is not the any other number product property. For any of these equations, you need to make sure that they're set equal to 0 before you begin either the quadratic formula or factoring. Obviously, for completing the square, there's kind of a different method. We look to get rid of that C term on the one side, but for these two other methods, we're just going to want to make sure that we are setting them equal to 0 before we move on. So you should get x equals -3 and x equals -2 as your two answers. This one over here is not factorable, so this is where we're going to use one of our two methods. I'm going to go ahead and use the quadratic formula. So I'm going to say -5 plus or minus the square root of 5 squared, which is 25, minus 4 times 4 times -19, and that is all over 2 times 4. Okay, and then once you plug in everything for quadratic formula, your next goal is to go ahead and simplify. The -5 is not going to be changed at all. On the inside, we're going to do 25 minus 4 times -19. And we're going to have 25 plus 304 on the inside. And then 2 times 4 we know is 8. And the last thing for this problem we're going to do is we're going to go ahead and simplify the inside there and make it 329. Now, 329 does not have any perfect squares that go into it. So actually, we're just going to leave it how it is, as -5 plus or minus square root of 329 over 8. That's going to be our final answer. For number 3, I'm going to look at this and automatically see that there's a GCF going on here. What's nice is that because we're solving and we're not necessarily factoring, and we're not necessarily rewriting into a different form, we can just go ahead and take out this 2 and kind of ignore it. So if you think about it, if I pull out a 2, I'm left with x squared minus 2x minus 1, which I can ignore this 2 and not worry about it anymore, because if I divide both sides by 2, it'll go away. So I end up really with 0 equals x squared minus 2x minus 1. Now, when I look at this, it kind of looks like it might be factorial, but in reality, it's really not. The only things that multiply -1 are -1 and 1, and those do not add up to -2. So again, I'm going to have to use quadratic formula. So we're going to have negative b, which gives us a positive 2, plus or minus the square root of b squared, which is 4, minus 4, and then a, which is 1, and c, which is -1, and that's going to be all over 2 times 1. Now when I go to simplify, I'll simplify the inside here. So you have 2 plus or minus the square root, and then if you look here, 4 times 1 times -1 is going to give us a -4. So it's going to be 4 minus -4, it's going to give us a positive 8 all over 2. And then I can simplify this further because a perfect square comes out of here. 4 goes into 8, so I can pull out a 2 from that because that's a square root of 4. So 2 plus or minus 2 root 2 over 2. And then you'll notice how I have a 2 in each part up top here. That means what I could do is factor out a 2 and then cancel it. But when you see it in each kind of term in your numerator, you can just go ahead and cancel, cancel, cancel. And we're going to end up with 1 plus or minus the square root of 2 is equal to x. Okay, that's problems 1, 2, and 3. Okay, and then down here we'll go again. So over here you can see we do not currently have this set equal to 0. So if I want to use quadratic formula, or if I want to factor, I cannot currently do that. So in order to do that, I'll have to move this 5 back over to use one of those two strategies. Now, what's nice, well, not really nice, but when I move this over, I'm going to notice that this one is not factorable. There is nothing that's going to add to 20, but multiply to -5. That's just not going to happen. So, again, I'm going to have to use quadratic formula. You'll see you get pretty good at it after you use it a bunch. So, -20 plus or minus the square root of 400 minus 4 times 1 times -5. And then all over 2 times 1, so it's going to be over 2. And then we'll go ahead and simplify in here. 4 times 1 times -5 is going to give us a -20. So 400 minus -20 is going to give us a positive 420. And 420 does have a perfect square that comes out of it. In fact, 4 does. So we can go ahead and take out the square root of 4, which is 2. So plus or minus 2. And we're left over with 105 on the inside. And then in the denominator, again, we have 2. And again, you can see that 2 goes into both terms of my numerator. So I can cancel out a 2, cancel out a 2. I know that this is really 2 times 10. So I cancel out that 2. So I'm going to have -10 plus or minus the square root of 105. Okay? Next one over here, I'm going to go ahead and make sure this is set equal to 0 once again. So 3x squared plus 15x plus 18 equals 0. Yes, that's a 15. I just made it worse. All right, well, that's 15. You know it. Again, I can see a GCF, so I'll go ahead and take that out. So I'll take out this 3. So I'm going to have x squared plus 5x plus 6. And again, I can kind of ignore this 3 out front because this said equal to 0. I can divide both sides by 3 and then I don't have to worry about it anymore. So really I'm just looking at this inside here, and it should look kind of familiar because we've kind of seen this exact same problem earlier on this paper. Okay, so I actually know that this is factorable. So we'll not worry about the 3. We'll go ahead and factor this. Get x plus 3 times x plus 2. And then we already know the answers to what our value for x is going to be. It's going to be that x equals -3 and x equals -2. Easy peasy, lemon squeezy. Up here, I'm already set equal to 0. I am missing a C term, but I can see once again that I have a GCF. In fact, my GCF for this one is going to be 20x. And then what's left over is x plus 3. Actually, by taking out this GCF, I've now fully factored this quadratic, which is pretty nice. Whenever you can factor them, it makes it usually pretty easy to find the values of x. So now I know that x equals 0 and x equals -3. I just set each of my factors equal to 0. I'm not necessarily showing that, but 20x equals 0, x plus 3 equals 0, and then solving for x, I'll get that x equals 0 and x equals -3. Okay, I'm going to stop there for this video. So this is questions 1 through 6. If you have any questions on these, this is the video to watch on that. If you want to watch further and see some of the next sort of questions, especially this one, we start completing the square, make sure you stay tuned for the next video and watch that, and it'll help you out with those problems. Thank you guys for watching, and I'll hopefully see you tomorrow.